If you haven't watched the displacement versus distance tutorial, you probably should watch that before you watch this. So we're going to use the same kind of number line here, but now we're talking about the difference between speed and velocity. Speed and velocity. And speed is sometimes given by the symbol s, although I don't use that very often. A lot of times I use v, even though it's technically velocity, so I tend to confuse everybody on that, so I hope I don't. There is a difference between speed and velocity, but eventually it probably won't be too big of a deal for you to kind of interchange them. But normally we use v, and technically we should have a arrow over the top, a vector, because velocity is a vector quantity. Speed is a scalar quantity. And if we want to figure out an equation for velocity, velocity is just how fast you are changing your position. So the velocity vector is, for instance, if I was at a certain position, we'll say I'm here. This is my position 1, and here is position 2. And let's say that I go from here to here, and it takes me 3 seconds, we'll say 3 seconds to go from here to here. So how fast do I go from here to here? So what that ends up being is your displacement vector over your the amount of time that it takes to get there. A lot of times maybe we'll put a delta time on there, a change in time, because we might not, if we just say it took 60 seconds to get there, then we'll just put in 60. But, we could actually say that time 1 was at 10 and that time 2 was 70 seconds. And then so that the delta time would be 70 minus 10 or 60 seconds. So I might actually give you times when you're at this position. But generally I just give you the total time it takes to go from one place to the next, so we can just plug in a time for that. But if I look at this, your displacement vector from your last video, if you remember that, would be final position minus your starting position, and then all over the time. So in this case up here, my final position is at +1, and subtract my starting position is 1, 2, 3, 4, and I said the total time it takes to go from position 1 to position 2 is 3. So I end up with a -3 over 3, which equals -1 meters per second. Those are the units for velocity, meters per second. We're going a certain amount of meters in a certain amount of time or in a certain amount of seconds. So in this case here, I get an interesting thing. I get -1 meter per second. So how could I have a negative velocity? I can't be going slower than stopped, right? So it's important to remember this negative sign. All that negative sign means the direction that this velocity is going. So I am going to the left 1 meter every single second. So every second I travel to the left -1 meter. And if you come up here, I think that makes sense. We start here, and then after 1 second we should have gone 1 meter to the left, which we did. Another second, another meter to the left. And after the 3rd second, another meter to the left, and we would end up in position 2. So although both of my positions, 1 and 4, were actually positive values, the velocity was still negative because we were going to the left. The velocity was going to the left of where my positive values were. So we're going to have a negative velocity in that case. Let's do another one. Let's say this is position 1 right here, and over here is position 2. So my velocity vector would equal position 2, which is 1, 2, 3, 4, 5, -5 minus my starting position, 1, 2, 3, 4, 5, so minus a +5, all over, and let's just say that this took 5 seconds, we'll say. So we're going to divide, no, let's say 2 seconds. We're going to go from here to here in 2 seconds. So I'm going to divide that by 2. And so minus 5 minus another 5 would be minus 10 divided by 2, and that would equal negative 5 meters per second. So what this means is that we would go 5 meters to the left every single second. So if we started here, after 1 second, we would have gone 5 meters to the left. 1, 2, 3, 4, 5. And after another second, we go another 5 meters. 1, 2, 3, 4, 5. That would put us in position 2. So we have a negative 5 meters per second. Negative because this velocity, this object, is traveling to the left. And let's do one more, shall we? Let's say here is position 1, and here is position 2. There's position 2, there's position 1. So this velocity vector would equal my final position, which is at plus 1, minus my starting position, which is 1, 2, 3, 4, negative 4. So 1 minus a negative 4. And we'll say this happened in 2 seconds also. So 1 minus a minus 4 would be 1 plus 4. That would be 5 over 2, which would be 2.5 meters per second. This would be plus 2.5 meters per second, which means after every second, we went 2.5 meters to the right. So we started here at position 1, and after 1 second, we'd be about right here. And then after another second, we would be at position 2. So if you have a positive velocity vector, that means the object is moving to the right or in the positive direction, whichever that might be, because we could be going up and down too. And so we might have down as positive and up as negative. So positive would mean to the right, or positive could mean down. It depends on how we're going to designate our directions. But if you have a negative velocity, it means we're moving to the left or the opposite of the positive direction. So hopefully that makes sense on how we calculate. This is velocity right here, and we could have this be for a constant velocity where we're continually always going the exact same speed. We could use this as our equation, v equals d over t, and this will be a very important equation for only when we're not accelerating. In the next movie, we're going to look at acceleration, and when we're accelerating, you can no longer apply this because acceleration means that you're changing your velocity. So you can only use this equation if you know you have an object that's traveling along at a constant speed. So I hope that helps us with the difference between speed and velocity. We will QED that.